Hi, so today we've got another big piece of interesting kit. This is a Horiba ABX DX120 blood analyzer. So if you go to get a blood test, they put the blood in those little bottles and those get loaded into racks and churned through this machine, and it produces all sorts of different analysis based on various optical and other principles. This actually is in two pieces. This is the left hand side, and this piece actually goes on the right. Now I suspect these aren't actually meant to be taken apart other than at the factory, because there's a few sort of bits of tubing that have been cut off and so on. So I think these are sort of designed to be put together at the factory and not just taken apart, but it made it an awful lot easier to get in the car this way. And there's bits missing and some damage to this, so I don't think there's any realistic prospect of actually getting this to do anything. I've tried powering it up, but all I get is this sort of checkerboard pattern on the LCD. You can say there's a few bits missing, a few sort of random wires dotted around the place, so this is definitely going to be a pull it to bits job. Fortunately, there's a very detailed technical manual and some user manuals that I found online, which I've linked down below, so if you want to look in some of the more technical aspects of this. There's also a video, but unfortunately it doesn't have a soundtrack, but I'll pull some extracts out of that and combine that with some information not from the technical manual, just to show the actual operating principles. So basically, trays of sample tubes go in here. There's this sort of stepper slide arrangement here, which sort of slides across, and it also opens up this little door. Inside here, which we'll get to that a bit later, there's like a shaker mechanism that just sort of rotates the whole rack a few times to shake up the blood. So I think the samples probably come down into this tray, get moved across into this section. We'll have a look in here, and I think this is where some of the sampling is done. Some bottles here for the various reagents that are used in the process. And the other thing we've got on the right hand side, this is the SPS, which is the slide preparation system. This will take some of the blood samples and actually put them on a microscope slide and apply some chemical staining, and also print a barcode onto that slide, and then out the out the side of here you get like a rack of slides all barcoded, stained, ready to be put under a microscope. I'd imagine perhaps more state-of-the-art machines would actually sort of scan those electronically or do some automatic analysis on them, but this is designed to work with sort of being stuck over a microscope and actually have somebody have a look at it. And for reasons that are not entirely clear, there appears to be a Star Wars sticker on the front of this. I don't know, maybe they just give all their machines names, and this one happens to be called Obi-Wan. I found this little snippet of information from an equipment survey. Apparently looks like they made over 400 of these things with a list price of $213,979 each. Obviously there's a few different configurations, but rather serious piece of kit. I paid about 1/1000th of that price. Well, here are some extracts from the manufacturer's video. The blood samples tubes go into this rack. Then they get dropped down, two of them drop down into this carrier that then whizzes around to give them a bit of a shake up. Barcodes get read, then it grabs one tube out, sticks a needle up it to get the blood out. Then this goes through this sampling device, which is quite clever, because each of these loops determine the volume of the sample that goes to each part of the instrument. It uses these bubblers to homogenise the blood and I think dilute it as well. There's I think some optical analysis going on there as well. And it then uses an aperture to determine the size it passes an electrical current, and the different cell sizes block different amounts of current, so it can get some readings on the size of each cell that goes through the aperture. And it does some categorisation. I think this is another optical process, but it characterises different parameters to produce sort of a 3D plot of various parameters. This is the flow cytometer. This fires a blue laser beam and uses fluorescent markers that they add to indicate the presence of certain things. This is the slide preparation system, which is the right hand side of the instrument. So dunks dot of blood onto the slide. Then it smears it across using this smearer. This uses a tape, sort of an expendable tape, so I don't have to worry about cleaning it off afterwards. It just sort of goops it across the slide into a thin film. And then it gets printed. Then picked up and dropped into the carousel, staining applied, then rinsed off. This is an alternate way of doing single samples, so you can interrupt a batch by just sticking one slide in and it will just stick one through. So it looks like this rack here holds the blank slides. There's a rack mechanism here which looks like it pulls the slides into the unit here. There's some sort of liquid valve, so it could be that's where the sample comes from. Then there's a second motorised slide, so I think the blood gets put on it somehow here. It then goes through. There's all sorts of sensors and switches. There's some sort of optical sensors down here. Then the next thing, sort of this sort of slide, this rack runs round across the whole the front of the unit, so it goes through here. Now this is the actual thing that wipes the sample across the slide, to produce a thin film on the slide. Now what they do is, obviously to avoid contamination, the idea is fairly simple. It's just putting like a flat blade across the slide to spread it all out. And that blade is covered by an expendable tape that goes in here, so it's sort of like it uses a new piece of tape for each sample, obviously to avoid contamination. That then carries on across here down to here, and here we have a print head. So this, I think this, it looks like it's actually a dot matrix head. Again, we'll have a look at in detail once we get this thing a bit more apart. But so it actually prints a couple of lines of text across the slide. I think they use slides that have got like a sort of a white section on them. Yes, the slide goes into that wheel, and that wheel obviously rotates upwards to flip the slide up vertically. And then we've got this sort of crane assembly thing here, so we've got this sort of moves across. There's another motor here that can lift the whole gantry up and down. And then there's these sort of grabby things. You've got this Bowden cable here, which is taking the drive from another motor at the back. That looks like that's what actually grips the slide, so it can sort of take that slide from here, lift it up, move it across, and then it goes into this carousel thing over the right hand side. So it seems to have this sort of carousel arrangement, so the sort of little crane sort of drops the slide down into the carousel, and then the carousel, find the motor that rotates it, but basically the whole thing rotates. And then we've got these various sort of things that can dip down at various positions. Presumably it sort of sprays different reagents over, washes it over the slide as it goes through each position, so it's like a batch process as they all sort of rotate. In that same crane probably pulls the slide out, and then they come out, I think the slides come out here somewhere. They're stacked into some sort of magazine that they come out here. There's a ridiculous amount of mechanics and stuff in here. And this is actually the simpler of the two boxes, believe it or not. And surrounding all this area there's loads and loads of sort of little valves, filters, or I think these are filters. And back here we've got 3 little pumps. There's a heater assembly. I think that's obviously these sort of chemical reactions need to work at specific temperatures, so there's what looks like that's either a heater, it might actually be a Peltier or combination to get everything to the right temperature. There's this sort of, it's still got some sort of fluid in it. I'm not quite sure what that is. There's just tons and tons of Fluidics. There seems to be a lot of these boards. These I think are stepper controllers. There seem to be quite a few of yeah, apparently identical boards. Obviously there's loads of, I haven't actually counted how many steppers in here, but there's a lot, at least half a dozen. This I think is the control board for the printer. It's probably just, yeah, it comes with the print head as a complete mechanism from the manufacturer. So again, there's a whole load of valves and tubes and another little stepper motor back there. It's like a little power supply, sort of DC-DC converter, and a sort of control board. I think each one of these ribbons is coming from one of those stepper controller boards. So there's sort of a bit over a dozen of those, and obviously leads going all over the place to everywhere else. And we'll have a look at the electronics in detail a bit later on. So in fact, yeah, most of the electronics distributed around here are these stepper boards. The say there's the printer controller, stepper board, and just this one big controller at the back. And the other thing I found is this whole assembly of all these valves isn't screwed down, so that's, someone's clearly had that off and not bothered putting the nuts back on. I just saw this little block over the right hand side. Clearly some sort of drain. There's a sort of bit of tissue in there full of all sorts of coloured gunk. Guessing it's probably a tube coming out the bottom of there to a drain reservoir. This seems to be like some sort of purging pump, because this is actually on the sort of slide that's driven by yet another stepper motor. And it looks like it's got these sort of pump sort of pistons in there, so that when that pulls down it sort of sucks through, yes. So when that pulls down, it puts a vacuum into these to sort of, you know, for sucking presumably waste of some sort out. Although I'm guessing that isn't what it routinely uses, because I mean there's no obvious sort of way of it. It just literally seems to be coming down the side of these and sort of coming over this slotted bar. So I suspect that's not for sort of routinely clearing after each operation, but just maybe some sort of general clean-up or something, because it's not, you know, if it's pumping a lot of stuff routinely, I'd have thought you'd get a slightly more well-defined sort of path for the fluid. They just seem to be sort of pistons in a block of plastic, so probably PTFE or something. This is the power supply, which is somewhat overkill. It's actually housed in a sort of welded together steel box. Not sure whether that's for shielding or for sort of gunk proofing. Then we've got like a standard power supply, and then sort of looks like a heat transfer plate to transfer the heat out to the bottom. Now, okay, I can understand normal analyzer type things being very sensitive to noise and wanting to shield it, but I mean this thing is basically just a box full of motors. I don't think there's actually any significant sensitive stuff in it, but maybe that's just, it could be that maybe this is the same power supply enclosure I use on other equipment. But obviously, yeah, one issue is that, you know, if the one place you really don't want all these blood and reagents and gunk to go into it's the power supply, so maybe this is as much as anything for sort of gunge proofing as anything else. Right, I've gutted the SPS system fairly quickly because I wanted to get the metal base plate out to the scrap man while I still had access to the estate car. So here's one of the modules that came with it. This is something which is chilling the one of the liquids. Basically we've got a fan at the bottom, then a heatsink, and this is a Peltier cooler. I've just stripped off some of the insulation, and then on top here we've got this metal block with a sort of zigzaggy channel in it, so the liquid goes through here and gets chilled. This is a DC-DC converter and a simple on-off controller, and it seems to regulate it to about 4 degrees C. Surprisingly there's no adjustment on here, but you can see there's these black high precision resistors, so presumably they yeah, the process just defines it has to be this temperature, so there's no particular need for an adjustment. They just use precision resistors and then precision sensor. If it's accurate, my guess would be that's probably a PT100 or similar sensor in there. It could be a thermistor, but for accuracy you tend to use platinum PT100s or PT1000s. This is just a completely, yeah, there's no interaction at all. There isn't even any monitoring as far as I can tell from the rest of the system. So it just assumes that if this, as long as this thing is powered, then this thing's going to be at the right temperature. Right, this is the printer mechanism. It's a fairly standard looks like a 9-pin dot matrix mechanism with its own controller board. This is made by Citizen. I still find a few bits of info. I can't find any info on this controller board. I've deduced that it's 5 and 24 volt supplies, and when I turn it on, it just does a simple homing thing. It doesn't actually do anything else. I've tried sort of setting each of these switches in turn as if it does a built-in self-test, but it doesn't. There was a connector on this plug going into here, so there might be some extra sensors, you know, to tell it when there's something in front for it to print onto, but without any info on this board, clearly you can tell from this pinout this is obviously an RS-232 interface. Can't immediately get any obvious signs. Oh, so actually no, here this is where the sensors were. So this just disappeared into the bowels of the machine somewhere, into the main control board. So there may have been some other status, and probably things like, you know, the equivalent of a paper out sensor. So I would have thought anything else would have been done through the serial port. So that's what I'm guessing. So it may need to see sort of these open or closed or something. But so without any data on this board, probably not a lot you can do with it. You might be able to squirt some serial at it to get it to try and print something, but I don't think I can really be bothered. Right, in this SPS unit there's 4 of these little pumps. Looking at the construction, I'm guessing this is a diaphragm pump. So we've got like a sort of diaphragm here and then a sort of piston that pushes it down. Just fire it up. It sort of feels sort of like a bit sort of vibrating as you'd expect. Let's pull the lid off. Yeah, you can see this is the diaphragm that sort of bounces up and down. Then there's just this sort of valve plate and these little rubber valves that open and close. And the top manifold just sort of sits on the top of there. Right, this is the main valve assembly. You've got 15 of these little two-way solenoid valve units and just an absolute heap of plumbing between them. A couple of things at the end, there's the sort of chambers with what look like float switches, so that's probably just to maintain a reservoir of something or other and monitor when it gets full, or monitor that it's got a certain amount, so just a float on there, and that'll be a tube with a sort of the float will have a magnet on it, and the tube will be a reed switch inside to detect the position of the float. And there's also another bank of these. These are a different, I think it's just a different make of valve. These all seem to be sort of 3-way valves. I'm not sure whether they've used different ones on here, whether they've got different characteristics, or whether this is just a different option. Interesting, these don't seem to be screwed down. These are just sort of free to just float around, but I suppose the sort of tubing keeps them vague in the position they want to keep them in. But yeah, lots and lots of valves. I'm sure we'll see more, if not even more than this we've got here in the main analyzer unit. And here's another piece. This was driven by a stepper motor with a ball screw on it. So it looks like we've got a sort of piston here, which is just controlling volume of something. And I think this is also another piston. I can't remember if this was on the same or a different motor. But obviously this is a much thinner tube, so this is dealing with much smaller quantities. I think that's also just some sort of piston type thing. Right, so I've pretty much finished with this SPS unit. We've got loads and loads of these solenoid valves, the chiller, 4 little pumps, and 13 stepper motors with all sorts of various sort of lead screw and other mechanical bits. This lot will probably end up on eBay fairly soon because I haven't got any particular use for it. But there's a whole variety of sort of, you know, rotary things, linear slides, so if you're interested in building some quite nice sort of actually ball screw linear slides there, so quite some nice stuff for those mechanically orientated people. The stepper drivers, this is the stepper driver board. Haven't been able to find out any information on it. It's got it's RS485 driven, it's got this Ubicom SX28 processor and an SGS Thompson stepper driver. It clearly has some intelligence because there's various permutations of limit switches connected into here, so these obviously handle the limit switching and probably the step and sort of some of the motion control, but I've not been able to find any information on the net. I don't know whether these are sort of custom for Horiba or whether, I'd imagine they may well be either a standard or a semi-standard part, but possibly sort of predating internet info. I've tried, you know, an image search on 485 stepper motors. The only name on there that I could see was Albassa, and a hint that it's probably French because the switches are labelled Capteur, but other than that I've not really found any information at all on these. Right, this is the This is the main control PCB that sits in the back of this. Nothing hugely exciting. Obviously all the connections are these IDC ribbon cable connectors. Some of them are ribbon, some are crimp connectors, but they're all using the same type of plug, which is well, there's no can't see any keying or anything, so I can't see anything to stop you actually plugging the wrong type of connector into the wrong socket, which isn't brilliant. Nothing hugely exciting here. We've got a load of ULN 2003 drivers for all the solenoid valves, some filters, and there's a lead for each one and a test point for each one. So these are surface mount test hooks, which are quite nice, and those filters just as sort of noise filtering. There's some RS232 drivers and stuff down here. There's an Altera Max CPLD, which I'm guessing is probably being used as an I/O expander. Main processor here is an NEC V753, and some just RAM sat next to it. Other than that, it's all sort of pretty straightforward. There's a voltage regulator. I'm sure that'll be just taking the incoming 24 volts and generating a low voltage sort of 5 volt supply for all the logic down there. The only slightly unusual thing, the way the machine's constructed, basically this rear is accessible when you pull the back off the machine. So for example, there's a fuse which is accessible here on the back. And the other slightly unusual thing is this is actually a socket for an SO packaged EEPROM or OTP ROM. So you sort of lift it off and then these little doors come open. And on the side we've actually got the software. So again, so that's still out, you know, so it can be upgraded fairly easily. This is probably a bit before the days of sort of easy flash updates. And this is, there's actually a flash, this is an AMD 29F2000, but the fact that it's in a socket probably means they never actually used it as flash. They just, you know, it was just a fairly readily available chip that they could put in a socket to use for doing field upgrades. Well, that's the SPS part of it pretty much covered. I think I'll leave the main analyzer to probably one or maybe even two more videos, because that's going to be somewhat involved. I'll just give you a little sneak preview though. So we've just got tons and tons of, there's pneumatic cylinders, there's crap loads of Fluidics stuff in here, there's an optical bench, big rack full of boards, and just like those boxes of chocolates where you suddenly find there's another layer underneath, you open this up, there's even more stuff back here. So I think this is going to take quite a lot of time.